Okay, so that is one of those ways of making alkenes. Another way of making alkene, number two, that is of synthesizing alkene, is by decarboxylation of carboxylic acid. It's easy. Let me write it. Decarboxylation of carboxylic acid. Carboxylic acid. So decarboxylation, that is, we remove the carboxylic of that acid. The carboxyl part of the acid is removed. So that is what they mean by decarboxylation. So this one is achieved by heating a sodium salt of a carboxylic acid with soda lime. So when we say lime, soda lime is a mixture. It's a mixture of sodium hydroxide and calcium oxide. So this is soda lime. I can say NaOH plus. So I will just change this one to plus. It's the same thing. So this is soda lime. So let's see how we achieve this. Remember we said it's when we heat sodium salt of carboxylic acid. So this is carboxylic acid, for example, HCOOH. This is methanoic acid. So instead of having this one as methanoic acid, this one becomes, the H will not be there. H will be replaced with a sodium atom. So this is sodium salt of methanoic acid. So let's generalize this, remove this hydrogen, and then we'll put R there. So R for any groups, can be hydrogen, can be something else. So we have RCOONA, so reacting with sodium hydroxide, NaOH, in the presence of calcium oxide, and then heat. So we are going to have R, this is RH plus sodium carbonate, Na2CO3. So the RH is our alkane. So remember I said R is an alkyl group. So alkyl can be CH3, and then plus this H again becomes CH4. So let's look at an example. So I will use ethanoic acid as an example. CH3, COOH, react with sodium hydroxide in the presence of calcium oxide and heat. We are going to have that CH3 will be there, CH3, and then plus one hydrogen, so it becomes CH4. Remember, this R is CH3, which is the alkyl group, CH3, and then plus another hydrogen becomes CH, and another hydrogen becomes CH4. So that is why we have CH4 down here, and then plus sodium carbonate. So that is another way of making alkane. So what are the properties of alkane? We have one other way, but let's continue. I think these two are sufficient for us. So what are the properties of alkanes? When we say properties, we're talking about either chemical properties or physical properties. So we'll talk about physical properties quickly. So one of the physical properties is we look at their physical state. How do they look? From carbon 1 to carbon 4. When we say from carbon 1 to carbon 4, we're talking about alkane that has only one carbon atom, like methane to carbon 4 means the one that has 4 carbon atoms, which is a butane. So this one means from methane to butane. So that is methane, ethane, propane, and butane. They are all gases at room temperature. So they are gases at room temperature. So from C5 to C17, they are liquid at room temperature, but they are liquids of different viscosity. Some of them are very light, they can flow easily. Some are thick, they cannot flow easily. From carbon 18 upward, C18 upward, or greater than 18, greater than or equal to C18, they are solid at room temperature. So when we say solid, remember your paraffin wax, remember your asphalt, the one they use to tar the road. So the main components of what they use to tar the road. So they are solid. Solid what? Solid alkanes. So what about their boiling point and their melting point? So of course, when you go, we are going from carbon 1 to carbon 18, you can see that we have gas, we have liquid, we have solid. So it means the boiling point increases with increasing carbon chain length. When the carbon chain gets longer, the boiling point increases at the same time. What about their density? So they are less, because they are organic compounds. Most organic compounds are what? They are less dense than water. That is why when you pour oil on water, or you pour water to oil, water will find its way down, and then you have the oil on top. So they are what? They are less dense than water. They will float on water. So, and then density increases slightly with what? With increasing molecular weight, because it means this one will have lower density compared to this one, because this one will have low molecular weight. You can calculate molecular mass of CH4, compare it to that of C4H10. Of course, you know this one has smaller molecular mass compared to this. So in that case, this one will have a lower density compared to the other one. So what about their solubility? Of course, you will know that we said they don't mix with water. So it means they are non-polar. They are non-polar. So they are, if a substance or if a liquid is non-polar, that substance or that liquid can be solid. That substance is what? Insoluble in water, because water is a polar solvent. So being non-polar means they are insoluble in water, because water is a polar solvent. So if they are insoluble in water, it means they will be soluble in polar organic solvents. So soluble in polar organic solvents. So an example of that is you can mix kerosene with petrol, because kerosene is a non-polar substance, and petrol is also a non-polar substance. Or I can use paraffin as an example. Paraffin wax can dissolve in like in benzene, so you can dissolve in it. You can mix it with something like that, because both of them, they are organic, so they can dissolve each other. There's a rule we call like dissolves like. So they're only soluble in polar organic solvents, but insoluble in water. Okay, what about their reaction, which is their chemical properties now? So let's look at reaction of alkanes, reactions, their chemical properties. This is very, very important. Number one, that is common to them, and then we use them for that as well, is their combustion properties. Combustion means their burning ability. So they are that is their, of course I said we use them for, so that is their most important reaction. Alkanes, they burn in the presence of oxygen to produce carbon dioxide and water, and then a lot of heat, and that heat makes the reaction an exothermic reaction because the reaction releases heat to the surroundings. So it is an exothermic reaction. So, and that is why we use them as a fuel, because of their burning ability. We use them as what? As fuels. One of the reactions, the reaction for this, I will write the general equation for combustion of alkanes, so which is CnH2n plus 2. So this is the general molecular formula, remember? Plus 2 plus 3n plus 1 over 2 oxygen, and this one will give us NCO2 plus N plus 1 water, and then plus energy. So this will help you to write any equation regarding combustion of alkanes.